Hey Algebra 2, today we're going to be talking about the ellipse. An ellipse, basically, it's an oval, and the way an ellipse is created, the technical way, is basically it's a set of points that at any given point, if I were to add the distance from one focal point to that point, and also the other, the distance, if I were to say this here is distance 1, this is distance 2. When I add those together, that will be the same as if I were to actually take this point and call this distance 3, distance 4. So those are going to be equal. Again, so any point on this ellipse, even back here, when I add these two distances together right here, it will equal this as well. So that's how we draw the ellipse. I mean, it's going to be an oval. Well, just like the circle, we have, actually I'm just going to draw a brand new ellipse here. Just like the circle, we have a standard form for the ellipse. Okay, let me draw another one here. Okay, standard form for an ellipse. Okay, let me move this over. Alright. It looks like this. So standard form, again, is going to be x squared over a squared. Sorry, it looks like a D. Over a squared plus y squared over b squared equals 1. Now the question is, what is a, what is b? Sorry, trying to clear my throat here. Alright, for an ellipse, okay, a is the distance from the center, okay, to the farthest point, okay, farthest point on the ellipse. So the center of the ellipse to the farthest point. So in this case, what's going to be the farthest point is right here. So this distance here is A. Now, the axis that has the farthest, that has A, the axis that has the farthest distance, see this ellipse is wider than it is taller, we call this the major axis. Okay? Sorry, semi-major axis. Semi-major axis. Because again, this is wider than it is taller. So the y-axis here is actually playing the part as the semi-minor axis. Okay, so the semi-major axis has it's wider here than it is taller. So the further distance apart would be the semi-major. This would be the semi-minor. So an example of this in opposite, if I were to give you an ellipse like this, the y-axis now would be the semi-major. Okay? Then the x-axis would be the semi-minor. Alright. Well, this is standard form. This is the formula for standard form for an ellipse when also, okay, this is standard form when A is on the x-axis. Okay, so when A is on the x-axis, alright, and again, when it is wider than it is taller, this is the formula you're going to use. The other formula is y squared over a squared plus x squared over b squared equals 1. And so this is standard form, okay? This is also standard form when A is on the y-axis, okay? And again, A is always going to be on the semi-major. Whether it's the y-axis or the x-axis will vary. But A always relates to the semi-major axis. Okay, now the two other points that you're going to need to know are called focal points. And again, if I were to give you an oval here, or an ellipse, wow, that's really bad. Just going to do this. Okay, so if I were to give you this, what is going on? Jeez. Ellipse here. Try to center that up. The focal point, like I said, are the 2 points here, okay, that add up. The distances will be the same no matter where you're going to. So, there's a formula for that. We call this distance here C, okay, and F for focal point, okay. So, one focal point, F, is equal to the square root of a squared minus b squared. And again, this is focal point. Okay. The square root of a squared minus b squared. And something to know about the focal point is that it's always on the semi-major axis. On the semi-major axis. Okay. So, if I have an ellipse like this, I know the focal point is going to be on the x-axis because it's wider than it's taller. This is my semi-major axis, so I know my focal points will be here. So let's start doing some examples here. If I were to ask you to graph an ellipse, so if I were to give you 16x squared plus 25y squared equals 400, and I say find the coordinates of the ellipses, vertices, and foci. By the way, these are called vertices, okay? At the far ends of the ellipse, those are called vertices, okay? And these are the focal points. So this, vertices. That, focal point, okay? Those are both vertices. All right, so now we have our formula here, or we have an equation here, but if you notice the formulas for an ellipse, both formulas here, this is equal to 1, this one is also equal to 1, so we have to set this equal to 1 somehow. So the way we change the 400 to be 1 is just divided by 400, because anything divided by itself is 1. Okay? So now we can reduce 16 goes into 400 25 times. So we could say x squared over 25 plus y squared over 16 is equal to 1. Alright? So now I see here that the bigger number, okay, is under the x squared. So this is playing the role of a squared. This is playing the role of b squared. So in this case, to find a, we just take the square root of this value. So here, a is going to be 5, the square root of 25. B, the square root of 16, is going to be 4. So if I needed to graph this, okay, I'm going to graph this here. Oop. Start that over. Alright, so if I want to graph this, it says A is 5. And notice 5 is underneath the x. So therefore on the x-axis, I'm going to go over 1, 2, 3, 4, 5. There goes one vertex. 1, 2, 3, 4, 5. There goes the other one. It says B is 4, and it's underneath the y, so I'm going to go up. 1, 2, 3, 4. Here, 1, 2, 3, 4. Okay, so if I want to label this, this is going to be 5, 0, 0, 4, 0, negative 4, and negative 5, 0. So here's my ellipse. I apologize for this, not going to look great. Okay, here goes the ellipse. Not terrible, but not great. But it also says that what I also want you to find are the focal points. Now, the plural for focal points is foci. So you see this? That's plural for focal points. So, the way we do that, again, we have our formula. F is equal to the square root of a squared minus b squared. And this, so we have now 25 minus 16. Square root of 25 minus 16. Therefore, F is equal to the square root of 9 Square root of 9 is 3. So 3 is the distance between the center of the ellipse to the focal point. And again, the focal points, or the foci, will always be on the semi-major axis. So the longer axis, that's where the focal point is going to be. So I'm going to go over 1, 2, 3, and then 1, 2, 3 back. So this is negative 3, 0. This is 3, 0. And there you go. Now you're not connecting anything from the focal points. You're just plotting them. Okay? So again, we need to set this equal to 1. So we divide it by 400. We reduce these. The bigger number is going to be a squared, and we took the square root to find a. A is 5. B is 4. And then we're able to draw our graph. So 5 is under the x-axis, so therefore you go on the x-axis, you're going to go 5 left and right. 4 is underneath the y, so you're going to go up and down 4 to create our ellipse. Alright, now what if I asked you to write the equation of the ellipse, and I just give you this information. Vertices are positive negative 8, 0, and 0, positive negative 5. So I'm telling you what the vertices are. Well, the bigger number for the vertices is going to be a. So we know in this case, because 8 is bigger than 5, that 8 is a, b is 5. So this gives us enough information to write our formula. So the question is, what axis is a on? Well, my coordinates, if the number comes first and is 0 second, that means it's on the x-axis. Just like here, we have 5, 0, negative 5, 0. So I know these coordinates are on the x-axis, so x squared over a squared. If a is 8, a squared is going to be 64. Y squared over, and now here we have 5, so we're going to square that. For b squared, we get 25 equals 1. So this would be our final answer. Okay? So again, establish which one's a, which one's b. The greater one is a. The smaller one is b. And since it's 8, 0, we know that's on the x-axis. That's why we put it underneath the x. Alright? So what if I actually give you a little bit different information? The vertices are 0, positive negative 4. And I don't give you the other pair, but I tell you that the foci are on 0, positive negative 2. Now we don't know, is this A or B? So the way we find out is we look to the foci. And the foci will always be on the same axis as A. Okay? The foci and A will always match up. So I look here and I see 0, positive negative 2. Since 0 came first, I know that these coordinates are on the y-axis. And so since these are on the y-axis too, I know this is A. Again, foci will always match up with A. So if this is 0, a number, then, and this is also 0, a number, this has to be A. So I know I can say y squared over A squared, which is 16, plus x squared over, we don't know what b squared is though. This is the problem. We don't know what b squared is because they didn't give us the other set of vertices. So what we have to do is plug in some values. Or what we can do is we can say, well, f is equal to 2. The foci is equal to 2. So 2 is equal to the square root of a squared minus b squared. Therefore, to get b squared by itself, we're going to square both sides. Those cancel out. We get 4 is equal to 16 minus b squared. So I'm going to add the b squared to this side. I added the b squared and subtract the 4 and we get 12. Okay? B squared is equal to 12. So I'm going to go back to my equation and write a 12 in here. And there we go. That's our equation. Again, the key thing to remember is that the foci will always be on the same axis as the A. This is on the y-axis, this is on the y-axis, therefore that has to be A. Alright? And I know some of these can be pretty tough, but the more you do these, the easier it will be. Alright, so let's graph our equation, our ellipse here. So I'm going to rewrite it down here. we have x squared over 64 plus y squared over 25 is equal to 1. Okay? So again, we said a is equal to 8, b is equal to 5. Alright? So we have our y-axis. Here goes our x-axis. So a, since it's underneath the x, again, you're going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. There goes our one vertex. 1, 2, 3, 4, 5, 6, 7, and 8. It says b is 5. 1, 2, 3, 4, 5. Since it's underneath the y-axis, I go 5 up and down. 3, 4, 5. And then I make my ellipse. Okay. Again, it doesn't have to be perfect, but hopefully it looks somewhat like an oval. And again, always label. So 0, 5, 0, negative 5, 8, 0, negative 8, 0. And that is how we graph the ellipse. The biggest thing to remember, again, is that this needs to equal 1 before you figure out what a and b are. So that's the ellipse. Good luck with that, and ask questions at school. And I hope you're understanding. And if not, I want to work with you and help you to understand it. All right? Have a good day.